Imagine you have built a beautiful automation framework, but as soon as you try to replace one part of the framework with another one, everything starts to break. Have you ever thought, why does this happen? So hey testers, welcome back to Automate with Amit, and in this video series where I am covering solid principles, which is SOLID, and each character has its own acronym, and this video is going to be related to L character, which is Liskov Substitution Principle. And in this video we are going to understand what is Liskov Substitution Principle and how do we apply it in our automation framework with a very interesting story. So watch till end because this particular video is going to be very interesting to watch. And previous two videos were related to the S and O, which is S for single responsibility principle and O was open closed principle, and this video in continuation to that is Liskov substitution principle. So if you are not aware why these principles are used, then I would recommend you to watch my previous two videos as well. And these solid principles are very instrumental when you are designing any automation framework. So this is also going to be very helpful. So without wasting your time, let's start. So chalo, let's start from the basics. What is Liskov substitution principle? So Liskov substitution principle says that object of parent class should be replaceable with the objects of child class without affecting the existing functionality.
अरे कहना क्या चाहते हो?
Okay, so let's take an example of सूर्यवंशम movie. अरे हाँ वही जिसपे सेट मैक्स वालों ने दिखा के पागल कर दिया था. Tell me in the comment box if you have already watched that movie. So in the movie we had Bhanu Pratap, right? Father of Hira. So we will take him as a parent class, okay, parent class object. So Bhanu Pratap over here is parent class object and Hira is going to be child class object. Now Bhanu Pratap had so much of money, fame, power and respect also in that particular area. But on the other hand, Hira does not had all of these things, right? So in that sense, if you see what Liskov substitution principle says, parent class and child class, in between them, child class should be able to replace without breaking any functionality. So now here, if you see, Hira cannot match to his father's respect, money and property in that particular area, right? So in this case, what Hira is doing, Hira will not be able to replace his father in that particular area. But when Hira married Radha and eventually Hira also built that much of empire by doing business, he also got fame, he also got respect in that particular area. Now Hira is able to replace his father in terms of respect, property and the empire he had built upon. So in that case, Hira is able to replace his father in terms of all these parameters we talked about. So in that case, Hira is following LSP. But wait, there is a catch. Hira married to Radha without consent of his family as well as Radha's family, right? And that too, उसने भगा ले गया यार bullet पे. So here, Hira is not following Liskov substitution principle. So that's very simplified explanation of Liskov substitution principle and how we can implement in our automation framework. So let's see this example in the automation framework itself. Okay, so on this screen, if you see, this is browser driver and this browser driver has this start method, which is going to start the any particular browser, right? And since this is a parent class, so we have a couple of child classes as well. Firefox driver. So this is our child class, which is Firefox driver, and it's responsible to initiate Firefox browser. And similarly, we have Chrome driver, which is responsible for Chrome browser initiation, right? So now this is parent class and this is our child class. These two are child classes. Now this is our main method, right? Main class from where all this action is happening. So for in here, if you see, this is main method over here, which is calling this start automation. Okay, so in start automation, we are going to pass whatever browser name we are going to pass. Accordingly, it is going to start that automation, right? So if we pass Firefox, it is going to initiate Firefox browser. If we pass Chrome, then it is going to initiate Chrome driver. Now if you see again in here, this is browser driver parent class and this is child class. So in order to make this child, we need to use extend, right? Extends browser driver, right? We need to extend this browser driver here. This way it is going to extend this browser driver. Now Firefox driver is child class and browser driver is parent class. Now Chrome driver, again similarly we are going to extend browser driver in here as well. So this becomes the child class. Now in our main method over here, if you see, this is start automation. And what does this start automation has? Start automation has one browser name, which is either Firefox or Chrome. So we have what we have done. This browser driver basically object is null right now. So if you see over here what we are doing, so if we are calling browser equals Chrome, right, this particular parameter is Chrome, then we are going to initiate this as driver equals new Chrome driver. So we are going to pass this as Chrome driver. And again, if this object equals browser equals Firefox, then we are going to pass this as Firefox, right? Once initialized this based on the whatever parameter we are passing, we are going to call this driver. If a driver is not null, then start the browser, right? So at the moment, let's start to run. Let's see what it shows. So this is very generic implementation, right? So starting the browser at the moment, it is showing starting the browser. Why? Because none of the child classes has given any implementations, right? So let's give some implementation over here to override the functionality. So I had overridden this start method over here. So now child class has its own functionality, right? Now child is starting Chrome browser and Firefox is also going to start its own browser once it is invoked. Okay, so now if I run this here, then since I am passing which browser? Firefox, then Firefox browser should run. Okay, so now starting Firefox, and similarly if I just pass Chrome, then Chrome should run. Okay, so now if I just run, then starting Chrome browser, right? So this is very simple setup where parent is here and child is overriding, and Chrome is again overriding its own functionality, its parent's functionality. Now here if you see what we are doing, now you must be thinking where exactly this child class is able to replace parent object, right? So let me change this browser driver with Chrome driver. So here definitely Firefox would not work because Firefox is not going to because Firefox is not child class of Chrome driver. So I'm just for now I'm just making this as commented out now here. But if you see, it does not breaks the LSP because easily I am able to change the browser driver with Chrome driver. So now let me run this and see if it is working fine, right? This is working fine because I am able to run this Chrome browser without affecting anything. Like I changed the parent object with the child object, right? So over here it is working fine. I'm just changing again browser driver. Okay, so now it's previous one. Now coming to the marriage part of Hira, right? Where he was breaking the LSP. That means, what if Chrome has something else which is parent does not has and other child classes don't have, right? So now let's suppose this Chrome driver is going to have this one more method which is start incognito. Basically, Chrome wants that it should also have this incognito mode functionality feature. जैसे हीरा राधा को भगा के लेके गया था शादी करने, similarly he is also going to introduce a new feature which is starting incognito mode. So this Chrome is going to open in incognito mode. So similarly over here start incognito is there, right? Now if you are going to use this incognito mode method, it won't be able to access over here, right? you won't be able to access using this object, right? Because parent does not allow to start in incognito mode. So how you can implement this way of starting incognito mode of Chrome browser? So in here, how it can implement it? By using interface, right? So I have created one interface over here, incognito mode, and start incognito is the method over here. And if I just go in here, Chrome, and if I implement this method here, that means now if implements Chrome driver. So now over here, what I did, I have one incognito mode method, incognito mode interface, and this interface is going to have this start incognito, which is getting overridden in this, or this Chrome driver is going to give the implementation of this. And once it is done, then still we are seeing some problems in here by using this, right? So instead of using in this way, what we can do, we can use one line of code, which is, instead of this way, what we can do this way. Here we are doing two things. First is, we had created one interface in order to support that incognito feature. We had created this incognito mode, and once we had created this incognito mode, whichever child class is going to support incognito feature, we had that particular class is going to implement incognito mode, and it has given the implementation of that method. So start incognito has been implemented in Chrome driver method, Chrome driver class. And if we are going here, then we are doing one check. What check? Basically, we are just checking that it has driver, which is driver instance is here. So what are we doing here? We are giving a check, which is, we are just making sure that driver is supporting incognito mode or not. If that driver object is supporting incognito mode, that means it has already given the implementation in that particular method or in that particular class. Then it is going to, what we are doing here, we are casting. So we are making sure that driver is going to support this incognito mode, and through that we are calling this incognito here. Okay, so that way we have implemented incognito feature which was not being supported before, right? So that's what we did here, and now let's run and see if it is working fine. So right, starting Chrome browser in incognito mode and starting Chrome browser. Now if I just give Firefox and now run this, so now if you see, even if I had changed this Firefox and Firefox does not had that incognito mode implemented, then also it is not breaking my code. So this is how we implement Liskov substitution principle. I hope this way of storytelling and the way I presented this particular principle was helpful and you were able to understand this. Then please comment in the comment box and do let me know what different topics you want to listen from me. Please make sure to subscribe the channel as well, because this motivates me and your one like is going to help me a lot. So please subscribe, comment and like the video. I am going to put more videos on the similar solid principle topic. So stay tuned. See you in the next one.